Well, hello again and welcome to the VK6CS Fun with Amateur Radio channel. Just a little bit more on the FLdx2000 valve amplifier from the I don't know, from the late 60s, early 70s sort of era. This is actually running at the moment. You can probably see the fans rotating around. Just before I get into the video, I'm just going to show a little bit of video of the valve sockets, because one of the viewers was saying they've just bought one of these and they think that they may have a modified one. Now, I'll actually it'd probably be easier if I do it like that. Yeah, there you go. So that's the top one there. If you can see that, the light's not great in here. With the components on it. Now, I've drawn the circuit diagram in pencil of that, and it tallies with the circuit diagram that I've got, so it's not modified. What's happening is they're using the spare pins, the not connected pins on the valve base, to anchor components to, just as you would a solder tag. So there you go. That's like the all four valve bases, and I'm sure that is not modified. Okay. Now, the this input circuit here, I've got to be mindful that this is on, the HT's on. I thought it was a tank circuit to match the input to the amplifier, and I was a little bit worried that the fact that when the standby switch on the front of the amplifier is in off, that means this relay here, this relay won't activate, which means that it won't switch the RF into the amplifier, which means that the drive radio, the RF from the drive radio, comes in here, goes up through this coil, through the relay, and out through the antenna socket. And I thought, well, I don't like the idea of that very much, that little tune circuit remaining in circuit, in series with the antenna for the drive radio when the amplifier is off, effectively. So anyway, I looked at the book, looked at the instructions. Here it is. Here it is. Here, this is L1, and these two capacitors here. That's the what I thought was an input tank tuning circuit. It's actually not. If you read this blurb, it's a low pass filter, which is probably why they thought it was fine to leave it in circuit when the amplifier wasn't, because back in those days this amplifier would have been driven by a radio that was probably either an all tube or a hybrid. It certainly would have had tubes in the output stage and a tank circuit. You would tune into this amplifier, and they probably thought that additional bit of filtering was a good idea. With the modern day radios from a reputable manufacturer, the output of those is pretty clean, and that low pass filter probably could be taken out of circuit if you're that interested in it. If it was presenting a little bit, it does present just a little bit of SWR, with the drive radio going through to the dummy load over the back there. It's not connected to an antenna. So I don't know, it wouldn't make much difference whether I left that there or whether I removed that, to be perfectly honest, that low pass filter. I don't think it's providing enough of a mismatch to worry about it. Am I bothered about it having the input cleaned up from one of these modern solid state radios? No, I wouldn't worry about it, to be honest. Okay, now I was wondering whether that was a mod, because, as I say, on here on the circuit it's shown as being, between the relay, which would be on the other end of this line effectively, and the amplifier, whereas in fact it's between the RF input and the relay, if you see what I mean. So I looked at this and found that it is absolutely standard. What they've done here is absolutely standard. Okay, so if I look at that, this picture here, this image, now this is this photocopied manual thing, and as you can see, the RF comes in there just as it does in my amplifier, goes through this little low pass filter and then onto the relay. So this one, I would say this amplifier is completely unmodded in that regard. This little thing down here is a modification, this new era resistor. Again, I'm mindful the HT's on. Is an ALC modification. So someone's modded that just for a given radio, whatever they had, just to provide the right amount of ALC. Coming round to the front. Okay, you can see that there's 0 anode current at the moment. It is on, but I haven't switched it to standby. Now I'll switch it to standby, and you'll see the anode current has gone up to 50 milliamps. So the anode current now has just come off the stop there, it's gone to 50 milliamps. And the reason is that I've got the relay, the input relay active. If that relay wasn't active, then that anode current would stay on 0 even though the standby switch was on. Okay. Now I'll just go over to the power meter. We can see it's on the 2 kilowatt range, which is the second one up. The function is power, and it's switched to forward, and this is the output power into the 50 ohm Versaload oil filled dummy load. There we are. That's going up to about 500 watts. Now, coming around to the anode current, when I key it, it's going up to just below 950 milliamps. And what it says in the instructions is 900 milliamps maximum for SSB. So if I was talking on SSB, that'd be peaking up to about 900 milliamps probably. It might just squeak up to 940. So if we do a quick calculation and say, just to keep it simple, 1200 volts at 1 amp is 1200 watts DC input. We've got 500 watts coming out of the amplifier. So we have the difference is the difference between 1200 watts and 500 watts is 700 watts. That 700 watts has to be dissipated as heat by the output tubes. The output tubes have 40 watts anode dissipation each. So 4 times 40 is 160. And so you can see that with 160 watts of anode dissipation and 700 watts to dissipate as heat, they will glow very quickly if you just key it down and leave it running at full power. And it actually does say in this book, in the instructions, you know what they say, RTFM, read the flipping manual. On the page that deals with, you know, what band you're going to use, how to set the tuning capacitors up, how to tune it. At the bottom of that page it says, important, do not operate this linear amplifier at full DC input continuously more than 3 seconds. It should be for more than 3 seconds, and the reason is that the tubes can dissipate 160 watts and they've got 700 watts to dissipate, so they do not like it. They will glow. They'll glow up pretty quickly if you leave that key down. Now, what was I going to show you? I was going to show you something else. I can't remember if I... Oh yeah. Now, you'll find this hard to believe with such excellent presentation and production skills being demonstrated here, but I don't have a script. Ridiculous, isn't it? It's true. Okay, so looking at this, let's just zoom in on that thing, see a bit better. Looking at the MFJ945E tuner. Now I have that, or matcher to be more accurate. although it's called a tuner. It's got tuner written on it. I'll call it a tuner for the sake of the video, but it's an impedance matching unit. I have that connected between the drive radio, which is the Yaesu FT450 at the bottom, and the input to the linear amplifier. Because the input to the linear amplifier is not 50 ohms. Now, this didn't really matter back in the days when this was built, when it was being driven by a valve drive radio. That could just be tuned into the linear for optimum output power. But these modern solid state radios like to see a 50 ohm load. Now, I've got the meter on the FT450 selected to SWR so you can see it a little more clearly, but what I'm going to show you is, I'm just going to key it, and you can see the SWR there is, if you look at the radio, I don't know, it's 1.6, something like that to 1. And you can see on the little tuner here the reflected needle, which is this one here. That's the forward one sticking up there like that. The reflected one, the cross needle meter, is down here. So you can see there's a bit of SWR there. That's as good a match as I can get into this linear amplifier at the moment. Now, if I, by using this to improve the matching between the drive radio and the input to the linear amp, if I take this out of circuit like that, so now you'll see how it looks if this wasn't matching the impedance. It's SWR, see how high that's gone up to, and you can see on that meter there that it's 2.5 to 1. So the SWR is greatly increased. I'll just put the tuner back in. There we go. So you can see that's back down there again now, and that's down to, I don't know, 1.6 to 1, something like that. So so what I did was, I thought, okay, well, the input impedance of the amplifier is not 50 ohms. So what I did was I matched this as well as I could into the amplifier. Then I disconnected the drive radio, I disconnected the linear, I put the antenna analyzer on the input to the tuner, and I put a pot on the output, and I adjusted the pot until the antenna analyzer indicated the same SWR as I'm seeing at the moment, and I then measured the value of the pot, and it was 26 ohms. So the input to my valve amplifier on this band anyway is 26 ohms. Now what I'm going to be doing, I'll just show you the drive power to get that, got 28 watts there, 28 watts to produce that 500 watts of output power. So what I'm going to be doing is I'll do that test for maybe 20 meters, and I'll do it for 10 meters, and I'll see if the input impedance varies much around 26 ohms. Whatever it is, I'll take a midpoint, and then I'll make up a matching transformer. And what I'll do with that, hang on. Oh, actually, just what I'll do first, I'll just show you, I'll just take the tuner out of circuit, there we go, and I'll press that, you can see the SWRs come right up. Now I'll just show you what difference that's made to the output power. I can get in the right position. I'll tell you what, James May, yeah, heart out, that's good stuff. Actually, I'm surprised James May is not a radio ham. Okay, so now, I know Tim Allen is, isn't he? And Priscilla Presley, surprisingly. There you go. Look at that. Look at what that's done to that output power. So what's that? 250 watts? 300 watts maybe? And now I'll press the button to put the tuner back in circuit. Now we have a good match, or a much better match, into the amplifier, and we're back to our 500 watts. Okay, so I'll just find the circuit again. Let's find the circuit again. Okay, so what I'll do is, so So what I found was this input impedance here is about 26 ohms on 40 meters. So I'll do the same test for 20 meters, I'll do the same test for 10 meters, and if this is a similar sort of impedance, then what I'll do is I'll make up a matching transformer, 2 to 1 probably, something like that, and I'll put it between the relay and that point there. That point there, because this, remember, this low pass filter is on the input side of the relay. So that it's not actually where it's shown on the circuit. This point here, this capacitor leg here, that goes off to the relay to allow the RF to come into the amplifier. It goes through this, then it goes through a relay, then it goes through this capacitor. So what I thought I'd do is, between this capacitor and the relay, I would put a 2 to 1 matching transformer, and I think then I'll get 500 watts out of my amplifier without using the tuner to match the input, if you see what I mean. Okay, now there was one other test that I didn't do, and that is how saggy is the HT. How saggy is the HT? So where does the HT actually come into this thing? Well, there's going to be HT down here on that point there on these capacitors here. That's going to be the HT line there. Yeah, I think what I'll do is I'll probably make another quick video about that, so that when it's producing RF, how saggy is the HT line, because I'll need to sit the thing up, I think, to do that, and I'm not going to do that with it. I'm not going to do that with it running, because it's it's enough HT there to give me a very nasty bite indeed, probably enough to kill me. Although, having said that, I think I've had belts off of this sort of thing before, and I can still. I was going to say I can still remember the music. I could hear the music in my head. It was broadcasting on medium wave at the time, but it was only a low output transmitter. It was only about this sort of output power. Okay, alright, well, I'm going off at a tangent, so as always, I'll thank you for watching, and hope you found that interesting, and I'll catch you next time.